History tells us that civilizations rise and fall. Empires expand, weaken, and disappear. We're told this is human failure. But what if that explanation only describes the surface? What if collapse is not random, but cyclical? Not because of politics, not because of ideology, but because of forces beyond human control. Human history is almost always presented as a straight line, a steady progression from simplicity to complexity, from primitive tools to advanced machines, from scattered tribes to global civilization. It is a reassuring narrative, one that implies progress is inevitable and collapse is only temporary. Yet this model quietly avoids a problem that researchers across multiple disciplines continue to encounter. The archaeological record does not behave like a straight line. Instead, it appears fragmented, interrupted by sudden breaks where continuity should exist. Entire cultures vanish from the historical record with surprising speed, not over thousands of years, but sometimes within only a few generations. Cities are abandoned without signs of siege. Trade networks dissolve abruptly. Technologies once mastered are lost, and later cultures are unable to reproduce them. In many cases, there is no evidence of widespread warfare, no indication of long-term economic decay, no gradual transition from complexity to simplicity. There is only absence. Historians often describe these moments as collapses, yet the term itself may be misleading. Collapse suggests a slow structural failure, a weakening over time. But the physical layers preserved in soil and stone frequently indicate something far more sudden, an interruption rather than a decline. What makes this pattern especially difficult to ignore is its repetition. Civilizations separated by vast distances, languages, and belief systems experience strikingly similar endings. Their declines cluster around specific periods in deep time. These periods are not defined solely by social disruption. They coincide with abrupt climatic shifts, large-scale ecological change, and anomalies recorded in geological layers across multiple continents. Temperatures change too rapidly for adaptation. Animal species disappear at unusual rates. Unfamiliar materials appear suddenly in the soil, and just as suddenly, the record goes quiet. And this is where the story becomes more uncomfortable, because it is no longer only archaeology speaking. Ice cores preserve chemical signatures of atmospheric change. Ocean sediments record shifts in currents and temperature. Tree rings compress years of drought into tight bands of evidence. Different archives, different continents, and yet, in certain windows of time, they all point toward disruption arriving faster than expected. The conventional explanation treats each collapse as an isolated event, a local failure with local causes. Yet as more data accumulates, this explanation becomes increasingly strained. Because when independent societies collapse in similar ways, at similar times, without contact, coincidence becomes an insufficient answer. It raises the possibility that civilizations do not simply rise and fall. They move through a repeating pattern: construction, destruction, and forgetting. If that is true, then what we call history may only represent the most recent arc of a much older cycle. And the question we are left with is not whether advanced civilizations existed before us, but what interrupted them. Because once you allow for the possibility of a repeating pattern, a new kind of question appears. Not who caused the collapse, but what clock the collapse might be obeying, and whether that clock has ever stopped. If the human story truly followed a smooth upward trajectory, the evidence should reflect continuity. Knowledge would accumulate. Techniques would improve incrementally. Mistakes would be corrected, not repeated. Yet the archaeological record tells a different story. Again and again, researchers encounter what can only be described as discontinuities, moments where cultural memory appears to fracture. Writing systems vanish, architectural styles disappear, agricultural practices regress rather than advance. In some regions, societies that once organized labor on a massive scale suddenly return to far simpler forms of existence. Stone replaces metal. Oral tradition replaces written record. Population density collapses without a clear cause. What makes these transitions especially perplexing is their speed. In a purely human-driven decline, adaptation is expected. People migrate, they reorganize, they preserve at least fragments of what came before. But in many cases, that continuity is missing. Instead, later cultures often treat the remnants of earlier societies as mysteries. They build next to monumental ruins without understanding how they were constructed. They reuse stones but cannot replicate the techniques. They inherit the landscape, but not the knowledge embedded within it. Some archaeologists suggest this indicates a loss of skilled specialists. Others point to environmental stress. Both explanations may be partially correct, yet neither fully explains why knowledge itself seems to vanish so completely. Because even under extreme pressure, humans remember. Unless something interrupts not just society, but transmission itself. Across different continents, similar patterns emerge. Sudden cooling events, rapid shifts in rainfall, short-lived but severe disruptions that overwhelm social systems faster than they can adapt. These are not slow climate trends unfolding over millennia. They are sharp inflection points, changes measured in decades, sometimes even years. And layered within the same time frames, geologists identify unusual markers, thin, dark bands in sediment, microscopic materials that do not typically form under normal Earth processes, signals that appear briefly and then fade. Individually, each anomaly might be dismissed, but taken together, they begin to form a pattern that does not align neatly with human timelines. A pattern that suggests external stress arriving suddenly, globally, and with little warning. This is where the linear model of history begins to break down entirely, because linear history assumes causality flows from human decision to human consequence. War causes collapse, mismanagement causes famine, corruption causes decline. But the evidence increasingly suggests that, at certain moments, civilizations face conditions so extreme that human agency becomes secondary. At those moments, societies do not fail because they make poor choices. They fail because the environment they depend on changes faster than their systems can respond. And if those moments repeat, if they cluster around specific intervals, then collapse itself may not be an exception. It may be part of a larger rhythm. A rhythm in which civilization briefly flourishes during stable windows and is then interrupted by forces operating on planetary or even cosmic scales. This does not mean ancient people understood those forces in modern scientific terms, but it does raise a troubling possibility that some civilizations may have recognized the pattern long before we did, that they experienced the interruption firsthand, and that the structures they left behind were shaped not only by culture or belief, but by memory of catastrophe. If so, then the ruins scattered across the world are not merely remnants of progress lost. They are evidence of survival attempts, fragments of a lesson learned the hard way. And the deeper we look into the breaks in history, the harder it becomes to ignore one possibility: that civilization does not endlessly advance. It survives in cycles. And every cycle leaves behind a silence before the story begins again. Among all the collapses recorded in deep human history, one event stands out as both familiar and unsettling. Not because it is fully understood, but because it sits just close enough to the present to feel almost remembered. Researchers refer to it as the Younger Dryas, a sudden climatic reversal that interrupted the warming of the last ice age. In geological terms, It arrived abruptly. In human terms, it arrived without warning. What makes this period particularly important is not merely the cold itself, but the speed at which conditions changed. Temperatures in parts of the northern hemisphere appear to have dropped dramatically in a span far shorter than traditional climate models once allowed. Ecosystems that had been stabilizing were suddenly forced into chaos. Large animal populations declined. Vegetation patterns shifted. Human groups that had begun settling into more complex lifestyles were confronted with an environment that no longer behaved as expected. This was not a slow descent into hardship. It was a shock. Ice core data suggests that atmospheric conditions altered rapidly. Sediment layers point to increased dust and debris. In some regions, charcoal concentrations rise sharply, indicating widespread burning. Yet the cause of this sudden reversal remains debated. Volcanic activity alone struggles to account for its global reach. Ocean circulation changes explain part of the picture, but not all of it. What continues to draw attention is the presence of unusual materials embedded within the same narrow layers of soil dated to this period. Microscopic diamonds formed under extreme pressure. Elevated concentrations of platinum, a metal more commonly associated with extraterrestrial sources. These markers have been identified at multiple sites across different continents, separated by thousands of kilometers. Individually, such findings might be dismissed as anomalies, but collectively, they suggest an event that was both widespread and intense. Some researchers propose that Earth may have encountered debris from space during this interval, fragments large enough to disrupt climate without leaving a single, obvious crater. Others caution that the evidence is incomplete and interpretations remain contested. What matters most for our story is not which explanation ultimately prevails, but what the event represents within a broader pattern. The Younger Dryas is not remembered because it was the first catastrophe humanity endured. It is remembered because it is one of the few resets that remains clearly visible in the geological record. And yet, even this memory is fragmentary. Human societies did not record the event in writing. They carried it, if at all, through oral tradition, symbol, and myth. Later civilizations inherited landscapes already shaped by the aftermath without knowing the full cause. From their perspective, the world simply behaved differently than before. What is rarely emphasized is that the Younger Dryas appears to arrive at a very specific position in time. Not random, not isolated, but aligned with a broader interval that some researchers quietly note appears again and again when examining older layers of Earth's history. If such an event occurred once, it could be dismissed as coincidence. If it occurred twice, it might suggest vulnerability. But if similar disruptions appear at regular intervals, spaced far beyond the span of written memory, then coincidence becomes increasingly difficult to defend. The Younger Dryas may not be the anomaly. It may be the reference point. A recent example of something much older. A reminder of a mechanism that operates on timescales larger than civilizations, larger even than cultures. A mechanism that does not announce itself in advance and does not discriminate between those prepared and those unaware. If that is true, then the question is no longer whether a reset happened in the distant past. The evidence suggests it did. The deeper question is whether the Younger Dryas was the last time the cycle completed its turn, or merely the last time humanity was able to remember it. Once the Younger Dryas is placed within a wider frame, its uniqueness begins to fade. What initially appears as a singular catastrophe starts to resemble something else entirely, a repetition. When researchers extend their examination beyond the most recent Ice Age boundary, older layers of Earth's history begin to reveal similar signatures, faint but persistent, buried beneath tens of thousands of years of sediment. In these deeper layers, separated by immense spans of time, scientists have identified familiar anomalies. Elevated concentrations of platinum appear again, detached from known volcanic processes. Nanodiamonds, Microscopic crystals formed only under extreme pressure and temperature emerge in thin, dark horizons that cut across otherwise stable geological sequences. These materials do not disperse gradually. They arrive abruptly, marking sharp transitions in the record. What is striking is not merely their presence, but their distribution. These markers appear at sites scattered across continents, in layers dated far earlier than the Younger Dryas. Some are tentatively placed around 24,000 years ago. Others push back even further, approaching 36,000 years before the present. The dates are debated, refined, recalibrated, but the pattern persists. At each of these intervals, the same questions resurface. Why do these layers coincide with sudden ecological disruption? Why do they align with rapid climate instability rather than slow environmental drift? And why do they appear so widely, yet so briefly, before disappearing again? Mainstream models often treat these findings cautiously, and rightly so. Extraordinary claims demand rigorous scrutiny. Some researchers argue that terrestrial processes, still not fully understood, may account for these materials. Others note that the evidence remains incomplete, unevenly distributed, and difficult to interpret. There is no universal agreement and no definitive conclusion. But uncertainty does not erase pattern. Even where interpretations differ, the timing remains uncomfortable. These anomalous layers do not scatter randomly through deep time. They cluster. They recur. And when plotted against long-term climate proxies, they appear to coincide with moments of abrupt instability, points at which Earth's systems shift rapidly from one state to another. It is within these unstable windows that human presence becomes harder to trace. Archaeological continuity weakens. Tool traditions change suddenly or disappear. Population estimates decline. In some regions, habitation layers thin dramatically, suggesting not gradual migration but sudden disruption. What follows these periods is equally telling. After each apparent interruption, human societies re-emerge simpler than before. Knowledge does not pick up where it left off. Instead, it resets. Techniques are reinvented slowly. Monumental construction, when it returns, bears little resemblance to what came earlier. This repeated pattern challenges a deeply held assumption that knowledge, once gained, is rarely lost entirely. History suggests otherwise. Under the right conditions, even sophisticated understanding can vanish within a few generations, leaving only mute structures and confused legends behind. It is important to note that none of this requires a single, catastrophic impact. Some researchers suggest Earth may periodically encounter dense streams of cosmic debris, fragments dispersed enough to avoid a singular crater, yet sufficient to trigger widespread atmospheric and climatic effects. Others emphasize internal Earth systems pushed past thresholds by external stress. The mechanism remains debated. The interval remains approximate. The conclusions remain open. But the implication lingers. If disruptions of this magnitude recur roughly every 12,000 years, not precisely but rhythmically, then the Younger Dryas was not an isolated accident. It was part of a sequence, a visible notch on a much larger timeline. And that timeline does not begin with us. Human history, as written, spans only a narrow slice of this cycle. Everything before it exists in fragments, distorted by time, erosion, and forgetting. What remains are signals without explanations, markers without narratives, warnings without words. The deeper scientists dig, the more uncomfortable the symmetry becomes. Because cycles imply inevitability, they suggest recurrence rather than exception. And they raise a question that grows harder to ignore with each newly discovered layer. If Earth has passed through these unstable intervals before, and if civilization has repeatedly failed to survive them intact, then progress may not be a permanent condition. It may be temporary. And if the past is any indication, The most dangerous moments are not those we remember, but those that arrive after memory itself has been erased. Once the possibility of repetition is acknowledged, a deeper question inevitably follows. If these disruptions are not random, then what determines their timing? Why do signs of collapse, instability, and environmental shock appear to cluster around a similar interval, separated not by centuries but by tens of thousands of years? And why does that interval, again and again, seem to hover around the same number? 12,000 years. In scientific terms, this number is uncomfortable. It is too long for human planning, yet too short to ignore on geological scales. It sits in an ambiguous zone, one where planetary systems, rather than human societies, begin to dominate cause and effect. One of the first mechanisms researchers examine when confronting this question is Earth's magnetic field. Far from being stable, the geomagnetic field is dynamic, restless, and imperfectly understood. It drifts, it weakens, and at irregular intervals it undergoes dramatic changes. Magnetic pole shifts do not occur on a neat schedule, but they are not entirely random either. Geological evidence preserved in volcanic rock shows that Earth's magnetic field has weakened significantly many times in the past, sometimes collapsing to a fraction of its current strength. During these periods, the planet's protective shield against cosmic radiation is compromised. This matters more than it first appears. A weakened magnetic field allows increased levels of charged particles to reach Earth's atmosphere. Satellites today are already affected by such anomalies. In the past, without technological buffers, the consequences would have been entirely environmental. Changes in atmospheric chemistry, increased radiation exposure, potential disruptions to climate systems already under stress. Some studies suggest that major magnetic excursions may coincide with abrupt climate events, not as sole causes but as amplifiers. When Earth's internal defenses weaken, external stress becomes more consequential. At the same time, researchers studying ancient climate patterns encounter another unstable system, the global ocean conveyor. Known as the Atlantic Meridional Overturning Circulation, or AMOC, this vast network of currents redistributes heat across the planet. When it functions normally, climates remain relatively stable. When it slows or collapses, the effects can be rapid and severe. Paleoclimate data indicates that sudden cooling events, including those associated with the Younger Dryas, align closely with disruptions in ocean circulation. Ice melt alters salinity. Salinity affects current flow, and once critical thresholds are crossed, the system can shift abruptly into a new state. What is striking is how often these different systems appear to destabilize around the same periods. Magnetic anomalies, ocean circulation changes, abrupt climate reversals. Each alone is disruptive. Together they form a cascade. Yet even this does not fully explain the regularity implied by the 12,000-year interval. To address that, some researchers cautiously widen their scope beyond Earth itself. Our planet does not move through space in isolation. It travels through a dynamic cosmic environment shaped by gravitational interactions, debris fields, and long-period cycles that extend far beyond human observation. Astronomers have identified streams of cosmic debris left behind by ancient comets. These streams persist for thousands of years, spreading out along orbital paths that Earth periodically intersects. One such structure, often discussed in this context, is the Torrid complex, a broad, diffuse trail of material capable of delivering repeated encounters rather than a single impact. Unlike a solitary asteroid strike, passage through a dense debris stream could produce a series of atmospheric events: airbursts, regional fires, increased particulate loading, enough to stress global systems without leaving a singular crater as evidence. The idea remains controversial. Evidence is incomplete. Models are still evolving, but the timing is suggestive. Some orbital reconstructions indicate that Earth's encounters with denser regions of such streams may recur on millennial timescales that roughly align with the intervals observed in the geological record. What emerges is not a single cause, but a convergence. A planet with shifting magnetic defenses, oceans capable of rapid reorganization, and a cosmic environment that is neither empty nor static. Under such conditions, stability may be the exception rather than the rule. The 12,000-year interval may not be a clock in the mechanical sense. It may be a resonance, a period where multiple systems, terrestrial and extraterrestrial, are more likely to align in destabilizing ways. If so, then the resets observed in human history are not punishments nor accidents. They are byproducts of a larger rhythm, one that operates independently of civilization. And if ancient societies sensed this rhythm, even dimly, then their monuments, myths, and warnings may have been attempts to grapple with forces they could not control, but desperately wanted to remember. Because the most dangerous cycles are not the ones that destroy cities. They are the ones that erase memory itself. Long before modern instruments measured magnetic fields or ocean currents, ancient cultures were already obsessed with cycles. Not cycles of seasons or harvests, but cycles of time itself. Across civilizations that had no known contact with one another, the same idea appears again and again. History does not move forward endlessly. It turns. One of the most persistent expressions of this belief is the concept sometimes referred to as the Great Year. In its simplest form, it describes a vast cosmic cycle governed by the motion of the heavens. Ancient astronomers observed that the stars themselves were not fixed. Over immense spans of time, the sky slowly changed. Constellations rose and fell along the horizon. Equinoxes drifted. What seemed eternal within a lifetime was revealed to be temporary across generations. This slow wobble of Earth's axis, now known as precession, completes a full cycle in roughly 26,000 years. What is rarely emphasized is that ancient traditions often divided this cycle in half, not at the beginning or the end, but at the midpoint, a transition, a dangerous passage. In several ancient systems, this midpoint corresponds to a period of instability, a time when balance is lost, order weakens, and the world becomes vulnerable. In later interpretations, this half-cycle was associated with decline rather than renewal. In the ancient Indian Yuga system, time unfolds through a sequence of ages, each marked by diminishing stability. While interpretations vary, some scholars note that when the cycle is recalculated using astronomical rather than symbolic units, a half-cycle emerges that closely mirrors the same 12,000-year interval appearing elsewhere. The details remain debated, but the convergence is difficult to ignore. Similar ideas appear in Mesoamerican calendrical systems, where long counts reset after vast periods. Not because time ends, but because it returns. In these traditions, destruction and creation are not opposites. They are phases of the same process. It is tempting to dismiss these ideas as mythological metaphor, and yet ancient observers were meticulous skywatchers. They tracked planetary motion with remarkable precision. They aligned structures to solstices, equinoxes, and stellar risings that would only occur at specific times. Their calendars were not casual inventions. They were tools. This raises a subtle but unsettling possibility. What if these cycles were not purely symbolic? What if they were based, at least in part, on observations of real, recurring instability? Not precise predictions, but pattern recognition passed down through generations that had witnessed abrupt change. Some researchers have suggested that ancient cultures may have noticed correlations between celestial events and terrestrial disruption. Increased meteor activity, unusual fire seasons, climatic irregularities tied to specific configurations of the sky. Without modern physics, They would not have understood the mechanism, but they could have recognized the timing. The torrid meteor stream, for example, is not a single event, but a vast river of debris through which Earth passes repeatedly. Modern astronomy confirms that this stream contains dense clusters capable of producing increased meteor activity over extended periods. While most fragments burn up harmlessly, the cumulative effects of repeated encounters, airbursts, atmospheric dust, regional fires, are only beginning to be studied. Ancient people did not need to calculate orbital mechanics to notice patterns. They needed only memory. Memory of fire falling from the sky. Memory of seasons failing. Memory of worlds changing faster than stories could adapt. If such memories were preserved, they would not survive as data. They would survive as myth, as warnings encoded in story, symbol, and ritual. Over time, the original meaning would blur, but the structure would remain. This is why ancient timekeeping often appears excessive. Cycles spanning tens of thousands of years seem unnecessary for agricultural societies concerned with survival, unless those cycles served another purpose, unless they were meant to preserve something far more fragile than crops. Knowledge of when danger returns. The unsettling implication is not that ancient civilizations predicted the future with precision. It is that they may have known instability was inevitable, that periods of calm were temporary, and that memory itself was at risk of being erased during each turning of the cycle. If that is true, then ancient calendars were not attempts to control time. They were attempts to survive it. They were reminders carved into stone and sky that the world does not remain stable indefinitely, that order gives way to chaos not once, but repeatedly, and that forgetting may be the most destructive force of all. Because a civilization that forgets the cycle is doomed to believe it is permanent, and permanence in a cyclical world is the most dangerous illusion of all. If cycles of destruction have repeated across deep time, then one assumption must be questioned immediately. That assumption is extinction. The historical record often treats collapse as disappearance, as though societies simply vanished. But disappearance from the surface does not necessarily mean disappearance from existence. Evidence suggests that not everyone was erased. Across multiple periods of disruption, small human populations appear to persist even as larger social systems fail. Genetic bottlenecks indicate survival under extreme stress rather than total annihilation. Archaeological layers thin, but they do not always end. Instead, they change character. Permanence gives way to mobility. Monumental construction gives way to concealment. Visibility gives way to avoidance. This raises an uncomfortable question. If certain groups survived repeated environmental shocks, how did they do so? And more importantly, what strategies would allow survival during events capable of collapsing entire civilizations? One answer emerges quietly but consistently: withdrawal from the surface. In regions scattered across the world, archaeologists have uncovered vast underground complexes whose scale and sophistication appear disproportionate to the threats traditionally cited. These are not small hideouts or temporary shelters. They are multi-level, subterranean systems capable of housing thousands of people for extended periods of time. Ventilation shafts run for kilometers. Water access is carefully managed. Food storage areas are integrated into the architecture. In some cases, entrances are deliberately concealed, not fortified. The design prioritizes invisibility rather than defense. Conventional explanations attribute these structures to warfare, invasions, raids, political instability. Yet when examined closely, these explanations often fall short. Many of these underground cities show no signs of hurried construction. They were not built in desperation. They were planned, expanded, maintained over generations. And perhaps most telling, They appear in regions where large-scale warfare alone cannot explain their existence. The underground city of Derinkuyu in modern-day Turkey is one such example. Capable of sheltering tens of thousands of people, it descends deep into the earth, with stable temperatures, secure ventilation, and controlled access points. The complexity of its design suggests long-term habitation rather than temporary refuge. Yet there is little evidence of prolonged siege that would justify such an investment solely for military defense. Researchers note that underground environments offer protection not only from human threats, but from environmental extremes. Temperature fluctuations are muted. Radiation exposure is reduced. Airborne debris is filtered naturally. In the event of widespread fires, dust loading, or atmospheric instability, the subsurface becomes one of the few consistently survivable environments. This observation reframes the question entirely. What if these structures were not built to hide from enemies, but to hide from the vents? Events that could darken the sky, poison the air, disrupt agriculture on the surface for years at a time. If ancient societies recognized the signs of an approaching cycle, even imperfectly, then retreat may have been their most rational response, not to prevent collapse, but to outlast it. Survival in this context would not mean preserving civilization as it existed. It would mean preserving people. Knowledge could be sacrificed. Complexity could be abandoned. What mattered was continuity of life. This may explain why survivors emerging after periods of disruption appear culturally diminished. They are not the inheritors of a golden age. They are the custodians of survival. Their priority is adaptation, not preservation. It also explains why knowledge fragments so completely. Writing materials decay, instruments corrode, oral tradition degrades under stress. Even deliberate attempts to pass information forward would struggle to survive years or decades of environmental instability. From this perspective, the surface ruins we study today are not the whole story. They are what was left behind, the visible remains of societies that could not move or chose not to. The survivors would have left fewer traces. Their success depended on invisibility, on leaving no signature that would attract attention from either human rivals or an unstable environment. This suggests that the archaeological record is biased toward failure. We see the cities that fell, not the shelters that endured. We study collapse layers, not survival strategies. And yet, the existence of large-scale underground habitation forces us to reconsider what ancient people may have known. You do not build for a threat you do not anticipate. You do not excavate entire cities beneath the earth without a reason powerful enough to justify generations of labor. If some societies prepared for periodic devastation, then they were not reacting blindly. They were responding to a memory of something that had happened before and would happen again. Which leads to a more unsettling question. If these people survived previous resets by withdrawing from the surface, did they also attempt to warn those who would come after them? And if they did, where would such a warning be placed so that it could endure a world periodically stripped of memory? If survival required disappearance, then warning future generations would require the opposite. It would demand visibility, permanence. Structures capable of enduring not just centuries, but cycles of destruction that erase memory itself. This presents a paradox. How does a civilization leave a message for the future when it knows the future may not remember who left it? The answer, some researchers suggest, may lie in stone. At sites scattered across the world, archaeologists have uncovered monumental constructions that appear strangely out of place in their supposed time. They are not cities, they are not fortresses, they are not tombs in any conventional sense, and they often appear before the rise of the complex societies traditionally believed capable of building them. Göbekli Tepe is perhaps the most unsettling example. Constructed at the end of the last ice age, This site consists of massive stone pillars arranged in circular enclosures. The stones are carved with intricate reliefs depicting animals, symbols, and abstract forms. Yet there is no evidence of permanent habitation. No hearths, no domestic refuse, no signs of daily life. This absence is not accidental, it is systematic. Göbekli Tepe was not a place where people lived, it was a place people visited. And what makes this especially puzzling is that the site was deliberately buried after its period of use. Layer by layer, the enclosures were filled in with debris, preserved rather than destroyed. This act of burial has long puzzled archaeologists. Why invest enormous labor into constructing monumental stone architecture only to hide it beneath the earth? One explanation suggests ritual closure. Another proposes social transformation, but neither fully accounts for the precision with which the site was sealed. Burial preserves, exposure erodes. From a long-term perspective, burial is one of the most effective ways to protect information from time. Some researchers have begun to ask whether sites like Göbekli Tepe were intended to function not as temples, but as repositories. Not libraries in the modern sense, but markers, anchors in time. Places designed to survive cycles of environmental instability, to be rediscovered rather than continuously used. The symbols carved into the pillars deepen this mystery. Many depict animals that do not appear to represent food sources or domesticated species. Instead, they resemble constellations as seen in ancient skies. Scorpions, foxes, birds. Creatures arranged in ways that may encode celestial information rather than mythological narrative. This interpretation remains controversial. There is no consensus that these carvings represent astronomical data. But the alignment of certain structures with solstices and star risings suggests that the builders were deeply concerned with the sky, with timing, with cycles beyond human lifespans. If so, then Göbekli Tepe may not have been a warning written in words. It may have been a warning written in pattern. A message that says simply, look up, look back, remember that time turns. What is most striking is that similar characteristics appear elsewhere. Massive stone platforms, enigmatic alignments, construction techniques that prioritize durability over utility. In many cases, these sites are later repurposed by cultures that clearly did not build them. They inherit the stones, but not the knowledge. This suggests a handoff that failed. If the original builders intended to transmit information across a reset, they faced an impossible challenge. Each cycle strips away context, symbols lose meaning, observations become myth, warnings become stories told without understanding. Over time, what was once precise becomes ceremonial. What was once data becomes religion. This process may explain why ancient myths often describe cycles of destruction by fire, flood, or darkness. These are not scientific explanations. They are memories compressed into narrative forms capable of surviving trauma. They preserve the idea of recurrence, even when the cause is forgotten. From this perspective, ancient monuments are not expressions of power or devotion. They are acts of desperation. Attempts to push knowledge through a bottleneck of chaos, hoping that something, anything, would survive. The builders may have known that most information would be lost. They may have accepted that the next civilization would misunderstand their intent. But misunderstanding is still better than silence, because silence means forgetting entirely. If even fragments of the message survived, then the cycle could be recognized again. The clock could be rediscovered, and perhaps one day the pattern could be broken, or at least anticipated. This reframes the role of ancient structures entirely. They are not relics of a naive past. They are the residue of civilizations that confronted forces they could not stop, but refused to face them unprepared. And if that is true, then the most important question is not what these monuments meant to their builders. It is what they were meant to say to us. Because messages meant to outlast collapse are not warnings about the past. They are warnings about the future. Once the idea of a repeating cycle is taken seriously, the focus inevitably shifts away from the past and toward the present. If civilizations before us faced recurring intervals of instability, then the most important question is no longer what happened to them, but where we now stand in relation to the same pattern. This is where the subject becomes uncomfortable, because it intersects with data that is still unfolding. Modern science has provided tools ancient observers never possessed. Satellites track Earth's magnetic field in real time. Ice cores reveal atmospheric composition stretching back hundreds of thousands of years. Ocean buoys measure current strength and temperature continuously. For the first time, humanity can watch planetary systems change as they happen. And some of what is being observed does not inspire confidence. Earth's magnetic field, long assumed to be relatively stable on human timescales, is weakening. Measurements indicate a measurable decline in overall field strength over the last 2 centuries. More concerning is the uneven nature of this weakening. In one region, known as the South Atlantic anomaly, the magnetic field has thinned dramatically, allowing increased radiation to reach lower altitudes. Satellites passing through this zone routinely experience malfunctions. Astronauts report heightened exposure. From a technological standpoint, this is an inconvenience. From a planetary standpoint, it is a signal. Geological records indicate that similar weakening has preceded past magnetic excursions and reversals. These events do not flip the field overnight, but they do involve prolonged periods of instability. During such intervals, Earth's natural shielding is compromised. What follows depends on what the planet encounters while exposed. At the same time, the climate system is exhibiting signs of stress that echo earlier disruptions. Rapid warming in polar regions is accelerating ice melt. Freshwater influx into the North Atlantic threatens to alter salinity gradients critical to ocean circulation. Several recent studies suggest that the Atlantic meridional overturning circulation is slowing, approaching thresholds associated with abrupt shifts in the past. These are not speculative scenarios drawn from ancient myth. They are observations derived from physical measurements. Yet what they describe aligns uncomfortably well with patterns reconstructed from earlier collapse intervals. The comparison is not exact. No 2 cycles are identical. But similarity does not require duplication to be meaningful. It requires correspondence. What complicates interpretation is that modern civilization has never experienced a full-scale planetary reset. Our records extend only through a period of relative stability. Our institutions, supply chains, and technologies have developed under assumptions of environmental predictability. Even our models are calibrated to conditions that may not persist indefinitely. Some researchers caution against drawing parallels too quickly. Earth's systems are complex. Human influence adds variables absent in earlier cycles. The future is not predetermined. These caveats are valid and necessary, but caution cuts both ways. Ignoring pattern because it is inconvenient carries its own risk. What makes the present moment distinct is not that danger is certain, but that awareness is possible. Ancient societies, if they recognized cycles at all, did so through fragments of memory and observation passed down imperfectly. We possess data, instrumentation, and a global perspective. If a cycle exists, this may be the first time a civilization can observe its approach rather than rediscover its aftermath. This does not mean catastrophe is imminent. Cycles unfold over centuries, not headlines. But it does mean that small changes now may represent early stages of larger transitions. The clock, if it exists, does not announce the hour. It advances quietly. This raises an unsettling possibility. That previous civilizations did not fail because they were ignorant or careless, but because they lacked the capacity to respond to planetary-scale change. They adapted locally, survived temporarily, and then rebuilt without fully understanding what had occurred. We may be approaching a similar inflection point, but with a crucial difference. We can see the systems shifting. We can measure the trends. We can compare present conditions with deep time records. The question is not whether the data is perfect. It never is. The question is whether waiting for certainty is itself a form of blindness. If ancient monuments were warnings, they were warnings without instructions. They could only say that collapse had happened before, not how to prevent it. The responsibility of interpretation falls entirely on those who find them, and interpretation is shaped by belief. If we believe history is linear, then every disruption appears manageable, temporary, fixable. If we accept that history may be cyclical, then stability becomes something to be protected, not assumed. The warning, then, is not carved into stone. It is embedded in comparison. The same signs that preceded earlier resets are appearing again, not as omens, but as data points. The meaning we assign to them will determine whether they remain curiosities in academic journals or signals that demand attention. Because cycles do not announce themselves as endings. They announce themselves as changes that seem survivable at first, and by the time their full shape becomes clear, memory has already begun to erode. The most dangerous aspect of any cycle is not the moment of collapse itself, but the period just before it. The interval when change is still subtle enough to be dismissed, when signals appear fragmented, and when the future feels distant enough to ignore. This is the stage at which most civilizations misread the clock. History suggests that societies do not fail because warning signs are absent. They fail because those signs are interpreted through assumptions that no longer apply. Ancient cultures likely faced a similar dilemma. Environmental shifts would have appeared uneven at first. One region suffers drought while another experiences floods. Seasons become unreliable. Animal migrations change. None of these events alone would demand radical transformation. Together, they form a pattern. But patterns are difficult to recognize while living inside them. Modern civilization is no different in this respect. The scale has changed. The tools have improved, but the psychology remains remarkably consistent. When data conflicts with expectation, it is often treated as noise. When change challenges deeply held narratives of progress and control, it is reframed as temporary. Even when long-term trends become clear, they are frequently interpreted as problems for future generations rather than present responsibility. This tendency is not rooted in ignorance. It is rooted in success. Civilization functions best under stable conditions. Stability rewards continuity. Systems optimized for efficiency become fragile when conditions shift outside their design limits. In such systems, acknowledging cyclical instability is not merely uncomfortable, it is destabilizing. This may explain why ancient warnings, if they existed, were encoded indirectly. A direct statement that collapse is inevitable would have undermined social cohesion. Instead, knowledge of cycles was absorbed into myth, ritual, and architecture. The warning survived, but its urgency faded. Today, the warning takes a different form. It appears in datasets rather than stories, in graphs showing magnetic field drift, in reconstructions of past climate thresholds, in statistical correlations that do not prove causation but refuse to be ignored. The challenge is not the absence of information, it is the absence of context. Without a cyclical framework, each anomaly is treated as isolated. A magnetic irregularity here, a climate shift there, a rare astronomical event dismissed as improbable. But cycles only become visible when individual events are connected across time. This is why the idea of a 12,000-year rhythm remains controversial. not because it lacks evidence entirely, but because it disrupts the assumption that human history occupies a privileged position. It suggests that civilization is not the end point of a journey, but a phase within a repeating process. Such a perspective alters the meaning of preparedness. Preparedness is no longer about preventing collapse entirely. It becomes about resilience, about preserving knowledge in forms that can survive disruption, about recognizing which systems must endure when complexity fails. Ancient societies may have attempted this imperfectly. Underground shelters protected life, but not culture. Stone monuments preserved memory, but not understanding. Each cycle began again with fragments rather than continuity. We face the same challenge, amplified by scale. Our dependence on interconnected systems increases vulnerability. Energy, food, communication, and data storage are tightly coupled. Disruption in one domain cascades rapidly into others. The very efficiency that defines modern civilization also compresses its margin for error. This does not mean collapse is inevitable. Cycles describe tendencies, not certainties. But ignoring tendency because it is inconvenient has never altered its outcome. The true warning, then, is not that a reset will occur at a specific date. That kind of prediction belongs to fiction. The warning is that civilizations repeatedly mistake stability for permanence. They assume that because conditions have held for generations, they will continue to hold indefinitely. They interpret resilience as immunity, and by the time evidence accumulates beyond denial, adaptation becomes reactive rather than deliberate. If the 12,000-year cycle exists, it does not function like a countdown. It functions like a season. You do not know the exact day winter begins. You recognize it by the signs: falling temperatures, shortening days, subtle changes that become unmistakable only in hindsight. The question facing us is not whether catastrophe is scheduled. It is whether we are capable of recognizing transition while it is still unfolding. Ancient monuments may have been built with this recognition in mind, not to predict the future, but to remind future generations that change is intrinsic to time, that history does not protect those who believe they have escaped it. The clock, if it exists, does not threaten us with destruction. It challenges us with awareness. And awareness, unlike stone or technology, cannot be inherited automatically. It must be chosen. When civilizations collapse, we tend to imagine the loss of cities, populations, and political systems. But the historical record suggests something even more fragile disappears first. Not people, not buildings, but knowledge itself. Again and again, across different eras, the most advanced skills of a society vanish faster than the society that created them. This pattern is difficult to reconcile with the idea of gradual decline. In a slow collapse, knowledge should degrade incrementally. Techniques should be simplified, adapted, preserved in some form. Instead, the archaeological record often shows abrupt discontinuity. Skills once mastered are not merely reduced, they are gone. Stoneworking offers one of the clearest examples. In several ancient sites, massive stone blocks were shaped, transported, and fitted with a precision that later cultures did not replicate. These are not isolated anomalies. They appear across continents, separated by oceans and millennia. When later societies encountered these structures, they often reused them, repaired them, or built around them, but they did not reproduce the methods. This suggests that the knowledge required was not passed down. Some researchers propose that these techniques depended on specialized groups. If those groups were small and highly trained, their loss during a sudden disruption could erase entire skill sets. Others suggest that the techniques relied on environmental conditions or resources that were no longer available after a collapse. Both explanations are plausible, yet neither fully explains the scale of disappearance. What makes the pattern unsettling is its consistency. The same loss occurs in metallurgy, engineering, astronomy, and surveying. Complex calendars are abandoned. Precise alignments are forgotten. Mathematical relationships embedded in architecture are no longer recognized by those who inherit the structures. This is not how human learning typically behaves. Even under stress, societies tend to preserve what works, unless stress overwhelms not just institutions but continuity itself. One possibility is that knowledge transmission depends on stability more than innovation does. Teaching requires time, trust, and predictable conditions. When survival becomes the primary concern, long-term instruction collapses. Apprenticeship ends. Oral traditions shorten. Written records decay without maintenance. Under such conditions, knowledge does not merely stagnate, it fractures. What survives is what can be carried easily: simple tools, basic practices, immediate survival strategies. What disappears are abstractions, measurements, methods that require precision, collaboration, and extended planning. This may explain why post-collapse societies often appear technologically regressed. They are not ignorant, they are constrained. They rebuild from what remains accessible, not from what was once possible. The implication is profound. If advanced knowledge can vanish within a few generations, then each cycle of collapse does more than reset material culture. It resets intellectual inheritance. The next civilization does not start where the previous one ended. It starts where memory allows. This reframes ancient ruins entirely. They are not the ancestors of later achievements. They are interruptions. High water marks reached and then abandoned, not gradually surpassed. Some researchers caution against romanticizing lost technologies. There is no evidence of ancient machines matching modern industry. That caution is warranted, but it does not address the central issue. The issue is not superiority, it is discontinuity. The question is not whether ancient civilizations were more advanced than we are. It is whether they reached forms of sophistication that were erased so completely that later cultures did not even know what questions to ask. This erasure aligns closely with the timing of environmental disruptions discussed earlier. When climates shift rapidly, when food systems collapse, when populations fragment, knowledge becomes a liability. It cannot be carried easily. It cannot be defended. It competes with survival. In such moments, forgetting may be adaptive, but adaptive forgetting carries a cost. It ensures that when conditions stabilize again, rebuilding begins without awareness of what failed before. Each civilization inherits the planet, but not the lesson. If this pattern has repeated multiple times, then human progress is not a smooth ascent. It is a series of peaks, each one forgetting the path that led to the last. This may be why ancient warnings relied on durability rather than clarity. Stone lasts when language does not. Alignment survives when explanation is lost. The message becomes implicit rather than explicit. Yet implicit messages require interpretation, and interpretation requires context. Without context, a monument becomes a mystery. A calendar becomes a myth. A warning becomes a story stripped of urgency. If knowledge vanished first in every previous cycle, then the most critical question for our own time is not whether collapse can be avoided. It is whether understanding can be preserved through instability. Because survival without memory ensures repetition. And repetition, in a cyclical world, is not progress. It is return. The disappearance of technology is only part of the story. What vanishes even faster is collective memory. Not individual recollection, but shared understanding. The invisible framework that allows a civilization to recognize what it knows, why it matters, and how it was learned. Without that framework, tools become artifacts rather than instruments, and knowledge becomes decoration rather than function. Anthropologists studying post-collapse societies often note a paradox. Survivors remember events vividly, yet lose the ability to explain them. Floods become myths. Fires become divine punishment. Environmental shifts become moral lessons rather than physical processes. Memory survives, but meaning does not. This transformation is not accidental. It reflects how the human mind responds to trauma and instability. During prolonged stress, abstraction becomes a liability. Complex explanations are replaced by narratives that can be remembered, repeated, and emotionally processed. Precision gives way to symbolism. In such conditions, the mechanisms behind catastrophe are less important than the fact that catastrophe occurred. The lesson becomes behavioral rather than analytical. Do not anger the gods. Do not build here. Do not ignore signs. These warnings persist, but the original causes dissolve into story. This explains why ancient myths often preserve accurate descriptions of events without preserving their explanations. Accounts of fire from the sky, darkness at noon, oceans rising suddenly, or seasons failing are found across cultures. They are strikingly consistent in imagery, yet vague in causality. The event is remembered. The mechanism is forgotten. Writing does not solve this problem as easily as assumed. Written language requires stable institutions to preserve, copy, and interpret it. During collapse, those institutions disappear. Scripts fall out of use, languages change, records decay. Even when texts survive physically, their meaning can be lost within a few centuries. Archaeology offers many examples of inscriptions that were preserved but unreadable until modern times. Without a living tradition, symbols become mute. Knowledge encoded without redundancy becomes fragile. This fragility suggests that ancient civilizations may have understood the limits of preservation better than we do. Instead of relying solely on language, they embedded information into forms less dependent on interpretation. Alignments that reveal themselves through observation. Ratios that persist in architecture. Spatial relationships that encode time without words. These are not efficient methods of communication. They are resilient ones. But resilience has a cost. Information encoded in this way is difficult to decode without context. It survives destruction but not misunderstanding. Each cycle preserves fragments, not wholes. Enough to provoke curiosity, but rarely enough to transmit intent. This may explain why later civilizations often stand in awe of ancient works without understanding them. They sense significance, but lack the conceptual tools to access it. Mystery replaces instruction. Over time, mystery becomes identity. Monuments are absorbed into cultural narratives. They become symbols of ancestry, divine favor, or lost golden ages. The original warning, if there was one, fades beneath layers of interpretation. The speed at which this transformation occurs is striking. Within a few generations, practical knowledge can become ritual. Within a few centuries, ritual becomes myth. Within a few millennia, myth becomes speculation. If collapse repeats on a timescale of 12,000 years, then each cycle erases not only material progress, but epistemological continuity. The next civilization inherits a planet shaped by predecessors but without access to their conclusions. This raises a troubling implication. Human intelligence may not be cumulative by default. It may be episodic. Each civilization reaches outward, learns what it can, then loses coherence under stress. What follows is not ignorance, but amnesia. Modern society assumes that digital storage solves this problem, that data, once recorded, is permanent. But permanence depends on energy, infrastructure, and compatibility. Without those, digital memory is among the most fragile forms ever created. A stone monument erodes slowly. A server farm fails instantly. If future collapse occurs under conditions that disrupt global systems, the majority of modern knowledge may not survive long enough to be rediscovered. Even if physical storage remains, interpretation will require languages, contexts, and reference points that may not endure. In this sense, modern civilization may be more vulnerable to memory loss than those that came before. Our knowledge is vast, but it is thinly distributed across interdependent systems. When those systems fail, access collapses faster than content. This returns us to the same dilemma faced by ancient builders. How do you preserve understanding across chaos? How do you communicate with people who do not yet exist, who may not share your language, values, or assumptions? There is no perfect solution, only trade-offs. Ancient societies appear to have chosen durability over clarity. We have chosen clarity over durability. Each approach reflects its environment. Each carries risk. If cycles of reset are real, then the greatest casualty is not technology, population, or even civilization itself. It is continuity. The thread that connects one understanding of the world to the next is repeatedly cut. And when that thread is severed, each civilization mistakes its rediscoveries for first discoveries. It believes it stands at the beginning of knowledge, rather than in the middle of a forgotten sequence. This belief is comforting. It is also dangerous. Because a civilization that believes it is unique will not look for warnings. It will not recognize repetition. And it will not understand why familiar patterns feel new. If memory fails before humanity, then survival alone is not enough. Without continuity, survival guarantees recurrence, and recurrence, without understanding, is indistinguishable from fate. When memory fails, language is often the first casualty. Words change meaning, symbols drift, scripts disappear. But stone endures. Across every known collapse, one medium repeatedly survives where others vanish. Not parchment, not metal, stone. This persistence raises a crucial question. If ancient societies understood that memory would be erased during periods of instability, what medium would they choose to communicate with the distant future? The answer would not be something fragile or complex. It would be something brutally simple. Heavy, resistant to time, fire, and neglect. It would be stone. Throughout the world, there are structures whose primary feature is not utility, but endurance. They are not efficient. They are not economical. They require enormous labor for minimal practical return. And yet, they appear again and again, often at moments when conventional models suggest societies should have been incapable of such effort. These structures share unsettling similarities. Massive blocks fitted with precision that exceeds apparent necessity. Alignments tied not to local geography but to celestial cycles. Locations chosen not for defense or resources but for permanence. What they lack is equally revealing. They do not contain written explanations. They do not depict clear narratives. They resist interpretation. This resistance may be intentional. A message written in words assumes continuity of language. A message written in symbols assumes continuity of meaning. A message written in stone geometry assumes only one thing: that future observers will still look at the sky. Stone monuments aligned to solstices, equinoxes, and stellar risings communicate through repetition. The event returns. The alignment holds. Time itself becomes the interpreter. This method is inefficient, but it is resilient. Sites such as Stonehenge, Nabta Playa, and numerous megalithic complexes scattered across Europe, Africa, and Asia demonstrate a fixation on cyclical time. Their builders invested immense effort to track movements that unfold slowly, far beyond a single lifetime. This suggests planning horizons incompatible with short-term survival alone. Why track cycles that take generations to repeat unless those cycles mattered? Archaeologists often frame these structures as ceremonial or religious. That explanation may be partially correct, but it avoids a deeper implication. Religion itself may have been the carrier of something else, a framework for preserving long-term observation when direct explanation was too fragile to survive collapse. In this sense, ritual is not superstition. It is compression. Complex knowledge reduced to repeatable action. Consider the labor required to quarry, transport, and erect multi-ton stones with limited technology. The cost is immense. The benefit, in practical terms, is minimal. These structures do not feed populations. They do not defend territory. They do not house communities. What they do is persist. They remain visible long after the societies that built them disappear. They anchor attention. They provoke questions. They ensure that future cultures cannot entirely ignore the past. This may be the point. If ancient civilizations faced resets that erased memory, then provoking curiosity may have been the most realistic goal. Not teaching future generations exactly what happened, but ensuring they noticed that something had happened. A stone circle that tracks the sun is not a warning in itself, but it tells future observers that time mattered to those who came before, that cycles were observed, that the sky was watched carefully. This becomes more significant when such sites appear to cluster around periods following major disruptions, not immediately after catastrophe when survival dominates, but during recovery phases, when populations stabilize but memory of trauma remains fresh. In that window, societies may have chosen to externalize memory, to store it in landscapes rather than minds, to accept that explanations would be lost but signals might endure. The silence of stone, then, is not absence of meaning. It is a deliberate narrowing of meaning to what can survive. This perspective changes how we interpret ancient construction. These sites are not failed attempts at permanence. They are successful attempts at durability under the assumption of forgetting. They do not say, "This will happen again." They say, "Pay attention to time." Because time, unlike language, cannot be erased. If the 12,000-year cycle exists, then stone monuments may be the last witnesses to each turning, not survivors, but reminders. Evidence that someone noticed the pattern and refused to let it vanish entirely. The question is not whether these structures prove intentional warning. The question is why so many cultures, separated by distance and belief, chose the same medium to communicate across deep time. Stone does not explain. Stone endures. And endurance in a cyclical world may be the most meaningful message of all. If stone was chosen as the medium, then symbol became the language. Not a language meant to be read aloud, but one meant to endure interpretation across cultures that would not share words, beliefs, or memory. In this context, the imagery carved into ancient stone takes on a different role. It is no longer decoration. It is compression. Across many of the world's oldest sites, the same kinds of figures appear repeatedly. Animals, abstract shapes, repeating patterns. They are not arranged as stories with beginnings and endings. They are presented as clusters, associations, relationships. Meaning is implied rather than explained. This is precisely what makes them resilient. Animals, in particular, are among the most persistent symbols in human cognition. They survive linguistic change because they are anchored in observation. A fox, a bird, a bull, a serpent. These forms do not require translation. They can be recognized even when their symbolic meaning has shifted. At Göbekli Tepe and similar sites, animals dominate the visual language. Predators appear more frequently than prey. Dangerous creatures are emphasized over domesticated ones. This is unusual if the site served a purely ritual or agricultural purpose. It becomes more intelligible if the imagery was intended to evoke threat rather than abundance. Some researchers have cautiously proposed that these animals correspond not to earthly ecosystems, but to patterns in the sky, constellations projected onto stone, a visual shorthand linking terrestrial danger with celestial timing. This interpretation remains debated, and there is no consensus, but the suggestion itself reflects an important point. The builders may have been encoding relationships rather than narratives. Relationships survive longer than explanations. Abstract symbols reinforce this idea. Repeated motifs, circles, pillars, enclosures, appear in contexts where practical function is minimal. Their repetition suggests emphasis. Emphasis suggests instruction. But the instruction is not explicit. It does not say what to do. It says what to notice. Notice the sky. Notice the cycle. Notice the return. If the goal was to preserve warning through collapse, then ambiguity was not a flaw. It was a feature. A clear explanation would become obsolete as languages changed. A symbol that invites interpretation can be rediscovered again and again. This may explain why so many ancient carvings resist definitive decoding. They were not meant to be solved once. They were meant to provoke recognition repeatedly. Each civilization would interpret them differently, but the act of interpretation itself would draw attention back to time, pattern, and recurrence. Over long intervals, even symbols degrade. Meanings shift. Rituals replace observation. What was once a warning becomes tradition. Yet tradition keeps structures active. It ensures maintenance. It prevents total abandonment. In doing so, it extends the lifespan of the message, even as the message itself transforms. This process is visible throughout history. Sacred sites are reused by successive cultures who do not share the beliefs of the original builders. Temples become churches. Circles become shrines. Monuments are reinterpreted rather than destroyed. Each reinterpretation adds a layer, but also preserves the core. The result is a palimpsest of memory, not accurate, but persistent. Critically, none of this requires that ancient builders understood every mechanism behind the cycles they observed. Pattern recognition does not require causal explanation. It requires only repetition. A civilization that survives a catastrophe and rebuilds may not know why the disaster occurred, but it can know when it tends to occur. If enough generations witnessed disruption aligned with celestial change, that alignment would become culturally significant regardless of its explanation. Over time, it would be encoded wherever permanence was possible. Stone, symbol, alignment. This also explains why these sites often appear to exist outside normal economic logic. They do not generate wealth. They consume it. Such investment makes sense only if the value lies beyond the present generation. Only if the builders believed the future mattered more than efficiency. In this sense, ancient stone sites are not statements of dominance over nature. They are acknowledgments of vulnerability. They accept that destruction will come again and attempt, imperfectly, to speak across it. The tragedy is not that the message failed completely. Fragments survived. The tragedy is that interpretation resets along with civilization. Each new society rediscovers the stones and asks the same questions, rarely aware that the questions themselves are part of the cycle. What remains consistent is the silence. Stone does not tell us what to fear. It tells us that someone before us feared something enough to build for it. That fear was not of enemies or gods or neighboring tribes. It was of time. Time that does not move forward forever. Time that returns. Time that erases memory and begins again. If this was the last language before forgetting, then its purpose was not to prevent collapse. It was to ensure that collapse was not invisible, to make forgetting incomplete. And if we are now standing among these stones asking why they exist at all, then in at least one sense, the message succeeded. The question that remains is whether recognizing the language is enough to change what happens next, or whether, once again, recognition will arrive too late. If civilization resets, then evolution should tell a different story. Biological evolution, after all, is not supposed to reverse. It accumulates, it adapts. It moves forward through selection, not repetition. And yet, when researchers examine the human record closely, they encounter anomalies that do not fit comfortably within a single, uninterrupted ascent. These anomalies do not suggest that humanity devolved biologically. They suggest something subtler and more unsettling. Cultural evolution appears to restart far more often than biology does. Anatomically, modern humans have existed for hundreds of thousands of years. During that time, brain size has remained largely consistent. Cognitive capacity, as far as can be determined, has not undergone dramatic leaps in the last 12,000 years. In other words, the hardware has been stable. What has changed repeatedly is the software. Periods of sudden cultural fluorescence appear in the archaeological record, followed by long intervals of stagnation or regression. Toolkits become simpler, artistic expression narrows, settlement patterns fragment. Then, thousands of years later, complexity reemerges as if rediscovered rather than inherited. This pattern is difficult to explain through gradualist models alone. If human cognition remained constant, why does complex culture appear, vanish, and reappear? Why does symbolic behavior surge and then recede? Why do technologies that require abstract planning and long-term coordination disappear entirely, only to be reinvented much later? One explanation points to population size. Smaller populations lose complexity faster. Knowledge transmission requires redundancy. When numbers collapse, rare skills vanish. This explanation is valid, but incomplete. It explains loss. It does not explain timing. Why do population collapses themselves appear to cluster around specific intervals? Why do they coincide with environmental instability rather than internal failure alone? Genetic studies add another layer to this puzzle. Analyses of ancient DNA reveal bottlenecks, periods when human populations were reduced dramatically. These bottlenecks are not evenly distributed through time. They align broadly with known climatic disruptions. Survival was possible, but continuity was not. What emerges is a picture of humanity repeatedly reduced to fragments. Not enough to go extinct, but enough to forget. Each time populations rebounded, they did so with the same biological potential, but diminished cultural inheritance. The result was not a continuation of a single trajectory, but a series of restarts. Civilization did not evolve once. It attempted itself multiple times. This may explain why early complex societies appear suddenly, with little evidence of incremental buildup. Agriculture spreads rapidly. Monumental construction emerges almost fully formed. Social hierarchies crystallize quickly. These are not tentative experiments. They are confident implementations. Such confidence is difficult to reconcile with first attempts. Some researchers suggest that these rapid transitions reflect latent capacity finally expressed under stable conditions. Others note that stability alone does not produce complexity without precedent. Learning curves leave traces. Trial and error leaves debris. In some cases, those traces are surprisingly thin. This has led to cautious speculation that later civilizations may have benefited from residual knowledge. Not direct instruction, but environmental scaffolding left behind by earlier attempts. Modified landscapes, altered ecosystems, domesticated species already shaped by human intervention. If so, then each restart did not begin on a pristine planet. It began on a world already touched by human hands, even if the memory of those hands was lost. This possibility blurs the line between prehistory and history. It suggests that what we consider the dawn of civilization may be the reemergence of something interrupted, rather than the first spark of something new. Importantly, this does not require lost supercivilizations or hidden technologies beyond evidence. It requires only repetition. Repeated attempts at complexity under windows of stability, each ending when that stability collapsed. The unsettling implication is that civilization is not humanity's default state. It is a conditional state. It exists only when environmental systems align favorably for long enough to allow accumulation of knowledge, coordination, and memory. When those conditions fail, civilization does not gently decline. It fragments. And fragmentation resets cultural evolution far more efficiently than biological evolution. From this perspective, humanity's story is not a ladder. It is a pulse. Expansion followed by contraction. Memory followed by forgetting. Order followed by simplification. If that pulse has repeated multiple times, then our current global civilization is not the culmination of history. It is the latest expression of a recurring experiment. An experiment whose outcome may depend less on intelligence or morality and more on whether memory can survive the next disruption. Because if biological evolution carries us forward, but cultural evolution keeps resetting, then progress is not guaranteed by who we are. It is determined by whether we can remain continuous. And continuity, as history suggests, is the rarest achievement of all. If cultural evolution were truly continuous, the record would show smooth transitions. Tools would gradually improve. Social organization would refine itself incrementally. Symbols would become more elaborate over time. But again and again, the evidence refuses to cooperate. Instead of continuity, researchers encounter gaps. Not small ones, but profound absences where development should be visible. Entire traditions appear suddenly, fully functional, without clear precursors. Just as abruptly, they disappear. These gaps are not evenly distributed. They cluster. They coincide with periods of environmental instability already discussed, and they challenge one of the most deeply held assumptions in archaeology, that culture always leaves a trail. In many regions, early symbolic behavior appears, then vanishes for tens of thousands of years. Cave art flourishes, then stops. Long-distance trade networks emerge, then collapse. Sophisticated tool industries are replaced by simpler ones, not because better tools were impossible, but because continuity was broken. This pattern has led some researchers to describe cultural evolution as punctuated. Long periods of relative stasis interrupted by brief bursts of rapid innovation. While this model explains sudden change, it does not explain disappearance. Innovation explains emergence, not erasure. Why would a population capable of symbolic thought abandon it entirely? Why would social complexity regress when cognitive capacity remains unchanged? One answer lies in stress thresholds. Complex culture requires surplus. Surplus requires predictability. When environmental systems become unstable, predictability collapses. Planning horizons shrink. Investment in long-term projects becomes irrational. Under such conditions, complexity is not adaptive. Simplicity is. This does not mean intelligence is lost. It means priorities shift. Symbolic expression gives way to subsistence. Social hierarchy flattens. Knowledge that cannot be immediately applied fades from use. But this explanation still leaves an unresolved tension. Some gaps are too large, too complete. In certain regions, thousands of years pass with minimal evidence of symbolic or technological advancement, followed by sudden reemergence as if from nowhere. This raises the possibility that recovery was not linear either. If populations were reduced to isolated pockets during disruption, their cultural trajectories would diverge. Some groups might preserve fragments of earlier knowledge. Others might lose it entirely. When conditions stabilized and populations expanded again, these fragments could recombine in unpredictable ways. The result would look like innovation, even if it were partial rediscovery. This may explain why similar ideas appear independently in different regions after long absences. Agriculture emerges in multiple locations. Monumental architecture arises in parallel. Calendrical systems develop separately yet share structural similarities. These are often framed as independent inventions, but independence does not exclude memory. It excludes communication. Memory can survive without coordination. Another uncomfortable gap appears when examining the speed of reorganization after collapse. In some cases, large-scale social structures reappear within a few centuries. This is fast, faster than expected if societies were starting from nothing. It suggests that latent knowledge, dormant rather than erased, was waiting for stability to return. Dormant knowledge does not leave obvious traces. It exists in habits, oral fragments, environmental modification, and selective breeding. It does not announce itself archaeologically. It waits. This challenges the way we define beginnings. The first farmers, the first builders, the first astronomers may not have been first in an absolute sense. They may have been first after forgetting. If this is true, then many of the gaps in the record are not empty. They are silent. And silence, in archaeology, is not proof of absence. It is proof of loss. Loss of population. Loss of continuity. Loss of transmission. This reframes the narrative of human uniqueness. We often ask why civilization appeared so late if humans were cognitively capable for so long. The question assumes a single trajectory, a single delay. But if civilization has appeared and disappeared multiple times, then lateness is an illusion. What we see is the latest recovery, not the first emergence. This also explains why myths of lost ages appear so consistently across cultures. Golden ages followed by catastrophe, worlds destroyed and remade. These are not historical records, but they may be cultural shadows cast by real interruptions. Memory stripped of detail but not of structure. The danger lies in misunderstanding these gaps as evidence of progress rather than fragility. We celebrate resurgence without accounting for the cost. Each recovery begins with less memory than the one before. Each reset narrows the channel through which knowledge can pass. If the cycle continues, then future archaeologists may one day study our remains and ask similar questions. Why did such complexity vanish? Why did knowledge not accumulate? Why does progress appear episodic rather than continuous? They may infer collapse from ruins, but they will struggle to understand forgetting. And forgetting is the central theme that connects these gaps. Not ignorance, not incapacity, but interruption. A civilization can survive physically and still lose itself intellectually. If cultural evolution restarts repeatedly while biology remains constant, then humanity is not climbing a ladder. It is walking a spiral, returning to familiar heights without remembering the path. Each ascent feels new, each collapse feels unprecedented, and each generation believes sincerely that it stands at a unique moment in history. Cycles make liars of first impressions. The gaps in our past do not tell us that humanity failed. They tell us that humanity endured, but without continuity. Survival carried us forward, but forgetting forced us to begin again. And if forgetting is the rule rather than the exception, then the most important question facing any civilization is not how advanced it becomes. It is how much it can remember when advancement is no longer possible. Every cycle leaves behind signals. The difficulty is never their existence, but their interpretation. In earlier eras, those signals were buried in ice, stone, and myth. Today, they arrive as data numbers, graphs, measurements that update quietly while attention drifts elsewhere. The question is no longer whether signals exist. It is whether we recognize them as part of a larger pattern. Modern science is exceptionally good at isolating variables. It excels at precision within narrow domains. What it struggles with is synthesis across timescales that exceed institutional memory. As a result, many contemporary anomalies are studied in isolation, detached from deep history. One of the most discussed is the behavior of Earth's magnetic field. Measurements over the last century reveal a steady weakening accompanied by accelerating pole drift. This is not speculation, it is observation. The magnetic North Pole is moving faster than at any point since systematic tracking began. The South Atlantic anomaly continues to expand, exposing satellites and aircraft to higher radiation levels. Individually, these phenomena are framed as technical challenges. Satellites are hardened, flight paths are adjusted. The problem appears manageable. But the deeper significance lies not in mitigation, but in comparison. Geological records show that similar patterns have preceded major magnetic excursions in the past, not catastrophes by themselves, but periods of vulnerability. At the same time, Earth's climate system is exhibiting behavior that resists linear explanation. Warming trends are uneven. Feedback loops are accelerating in some regions while lagging in others. Ice melt is not just raising sea levels, it is altering ocean chemistry and circulation. These changes are measurable, but their long-term interactions remain uncertain. The Atlantic meridional overturning circulation, a critical component of global climate stability, shows signs of slowing. Proxy data suggests it is weaker now than at any point in over a millennium. Models indicate that once certain thresholds are crossed, recovery may not be gradual. It may be abrupt. Again, this is not unprecedented. Abrupt climate shifts are well documented in the paleoclimate record. What distinguishes the present is not the novelty of change, but the density of concurrent signals. Multiple systems are shifting simultaneously, each within its own domain, yet increasingly difficult to separate. Add to this the cosmic environment. Near-Earth objects are tracked with growing sophistication, revealing a dynamic population of asteroids and debris streams. Meteor airbursts, once considered rare, are now recognized as more common than previously assumed. Most are harmless. Some are not. The statistical risk remains low but non-zero. In earlier cycles, such risks would have been invisible until impact. Today, they are cataloged, modeled, and debated. Awareness has increased. Certainty has not. This is where modern caution becomes a double-edged sword. Scientific rigor demands restraint. Correlation is not causation. Patterns must be tested, not assumed. These principles protect against error, but they can also delay recognition when phenomena span disciplines and timescales that do not align neatly. As a result, the idea of long-term cycles is often treated with suspicion, not because it is implausible, but because it is difficult to falsify. Cycles imply recurrence without precise prediction. They resist short-term verification. They challenge the narrative of continuous progress. Yet the refusal to consider cycles does not prevent them from operating. The present moment is characterized by a paradox. We have more data than any civilization before us, yet less consensus about what it means in aggregate. Each anomaly is explained locally. Each trend is debated within its silo. The broader pattern, if it exists, remains fragmented. This fragmentation mirrors the early stages of past disruptions. Signals appear first as inconsistencies, as exceptions, as noise at the edges of models. Only later, in hindsight, do they align into something recognizable. The danger lies not in misinterpretation, but in delayed synthesis. Ancient societies lacked the tools to see the whole. We possess the tools, but struggle with integration. Our models are powerful, but our timescales are short. Political cycles, economic incentives, and institutional structures favor immediate concerns over deep time patterns. This does not imply negligence. It implies limitation. If the 12,000-year rhythm is real, it would not announce itself through a single dramatic event. It would emerge as a convergence, subtle at first, denied as coincidence, only obvious once irreversible. The present anomalies may or may not belong to such a convergence. That uncertainty is real. But uncertainty cuts both ways. It does not justify dismissal. It demands vigilance. Because cycles do not repeat exactly, they rhyme. They manifest through different mechanisms under different conditions. The signature is not sameness, but alignment. Magnetic instability, climatic volatility, increased exposure to cosmic variables. None of these guarantee collapse. Together, they suggest susceptibility. The past shows that susceptibility matters more than cause. Civilizations do not need a single overwhelming blow to reset. They need a sequence of stresses that arrive faster than adaptation can occur. Stress layered upon stress until systems optimized for stability become brittle. If that is how previous resets unfolded, then the most important signals are not the dramatic ones. They are the quiet ones, the slow drift, the anomalies that seem manageable until they converge. We are living inside the data point, not observing it from a distance. That alone makes interpretation difficult, and it raises a final, unsettling possibility. That earlier civilizations also noticed anomalies, that they debated them, that they adapted locally and assumed stability would return, and that by the time the pattern became undeniable, memory was already beginning to fracture. If so, then the present moment is not unique because it is unprecedented. It is unique because it offers a choice that may not have existed before. Whether to treat anomalies as isolated problems or as signals of a rhythm humanity has encountered, forgotten, and encountered again. There is a reason long-term cycles are uncomfortable to confront. They undermine one of the most deeply rooted assumptions of modern civilization, that progress is cumulative and largely irreversible. A cyclical framework suggests the opposite, that advancement can be temporary, that complexity can dissolve, and that collapse does not require failure, only misalignment with larger systems. This idea runs counter to how modern knowledge is organized. Scientific disciplines are divided by necessity. Geophysics studies Earth's interior. Climatology examines atmospheric patterns. Astronomy looks outward. Archaeology looks backward. Each field produces insights of extraordinary precision, but rarely are those insights integrated across the spans of time required to recognize repetition. Cycles demand synthesis. They demand comparison between eras that exceed written history, institutional memory, and sometimes even disciplinary comfort. As a result, they tend to fall into the gaps between fields where responsibility is diffuse and certainty is hard to establish. There is also a psychological dimension. Humans are exceptionally good at responding to immediate threats. We are less adept at responding to slow, systemic change. When disruption unfolds gradually, it is normalized. Each new condition becomes the baseline against which the next change is measured. This process, sometimes called shifting baseline syndrome, ensures that awareness lags behind reality. In a cyclical context, this lag is dangerous. If each reset begins not with catastrophe but with instability, then the early stages will always feel survivable. Systems adapt locally. Problems are compartmentalized. The belief in control remains intact. By the time adaptation fails, the opportunity for deliberate response has already passed. History suggests that previous civilizations may have fallen into this same pattern. They did not ignore danger. They responded to it incrementally. What they failed to recognize was convergence. Multiple stresses arriving within the same window, reinforcing one another until resilience collapsed. Modern civilization is particularly vulnerable to this error because of its success. Global networks create the illusion of redundancy, but often amplify fragility. Supply chains optimized for efficiency lack buffers. Information systems depend on uninterrupted power. Specialization increases capability while reducing flexibility. In such systems, small disruptions can cascade rapidly. Yet because each disruption has a plausible local explanation, the larger pattern remains obscured. The idea of a 12,000-year rhythm is often dismissed as speculative because it lacks a precise mechanism. But this expectation may itself be a category error. Cycles in complex systems rarely have single causes. They emerge from interactions, feedback loops, thresholds crossed not by one variable, but by many. Demanding a single trigger may prevent recognition of a composite process. Ancient societies may have understood this intuitively. Without equations or models, they observed outcomes. They noticed that certain configurations of time and sky coincided with upheaval. They did not need to know why the cycle occurred to know that it did. Modern science, by contrast, seeks explanation before acceptance. This is a strength, but also a vulnerability. Explanation often lags behind pattern recognition. Waiting for complete understanding may delay response until response is no longer possible. This does not mean abandoning rigor. It means acknowledging that uncertainty does not equal irrelevance. One of the most telling features of previous collapses is that they appear obvious only in retrospect. Archaeological layers reveal abrupt transitions that were invisible to those living through them. What appears sudden from a distance unfolds slowly up close. We may be experiencing something similar now. Magnetic drift does not feel like danger. Ocean circulation changes are invisible to daily life. Increased cosmic exposure is abstract. None of these trigger instinctive alarm. They require interpretation. And interpretation requires a framework. Without a cyclical framework, the present anomalies remain unconnected. With one, they begin to align. The resistance to such a framework is understandable. Accepting cycles implies limits. It suggests that no civilization, regardless of technology, is exempt from planetary processes. It implies that control is conditional, not absolute. This is not a comforting message. But neither is it new. The ruins of past civilizations testify to the cost of assuming permanence. Each society believed in its own way that it had solved the problems of survival. Each was eventually proven wrong, not by malice or incompetence, but by scale. The forces involved were larger than politics, larger than culture, larger than intention. If cycles are real, then the most critical failure is not technological, it is conceptual. The inability to think beyond linear progress, the reluctance to see repetition as warning rather than coincidence. Modern civilization stands at a crossroads not because catastrophe is imminent, but because awareness is possible. We can compare present conditions with deep history. We can recognize familiar signatures. We can choose to treat anomalies as data points within a larger rhythm rather than isolated inconveniences. That choice does not guarantee survival. Nothing does. But refusing the choice guarantees repetition. Cycles do not demand belief. They demand recognition. And recognition, once achieved, alters responsibility. If we are not the first civilization to face these patterns, then we may also not be the last. What distinguishes us is not immunity, but opportunity. The opportunity to decide whether history is something that happens to us or something we finally understand well enough to remember when it matters most. Every cycle leaves behind debris, broken cities, altered landscapes, fragmented myths. But beneath those visible remnants lies something far more elusive: intention. What the people who lived through previous resets believed was worth carrying forward, even when they knew most of it would be lost. This is where the story turns inward. Because the most revealing aspect of past civilizations is not how they collapsed, but what they chose to preserve when collapse became unavoidable. When survival replaced expansion and endurance replaced ambition, priorities shifted. What mattered was no longer growth, but continuity. And continuity, in a world that repeatedly forgets, requires sacrifice. Ancient societies that sensed instability appear to have made difficult choices. They abandoned surface permanence in favor of concealment. They traded clarity for durability. They allowed meaning to erode if structure could survive. These were not signs of ignorance. They were acknowledgments of constraint. You cannot save everything. This realization may explain why ancient warnings are so frustratingly incomplete. They do not tell us what to do. They do not describe causes in detail. They do not offer solutions. Instead, they point. They gesture. They leave markers that say, in effect, something happened here. Something happened before, and it will happen again. The restraint is deliberate. A detailed explanation would not survive linguistic drift. A precise date would become meaningless after calendars reset. Even an accurate description of mechanisms would be useless to a society lacking the context to interpret it. What could survive was not information, but orientation. Look at time differently. Watch the sky. Expect change. This orientation may have been the most valuable lesson ancient civilizations could pass on. Not prediction, but humility. An understanding that human systems exist within larger systems that do not negotiate. Modern civilization has largely lost this orientation. We excel at control within narrow bounds, but we struggle with acceptance of limits. We assume that because we can solve many problems, we can eventually solve all of them. This assumption has shaped our institutions, our economies, and our expectations. But history suggests that limits are not challenges to be overcome, they are conditions to be respected. If previous civilizations were reset not because they failed, but because they encountered conditions beyond their adaptive capacity, then the lesson is not about morality or intelligence. It is about scale, about recognizing when problems are no longer local. This reframes the idea of warning entirely. A warning is not a prophecy. It is a change in perspective. It invites the observer to step outside immediate concerns and consider patterns that unfold over lifetimes, centuries, and millennia. Ancient monuments, calendars, and myths may have served this function. They forced attention toward cycles when daily life encouraged linear thinking. They interrupted the assumption of permanence. In doing so, they performed a subtle act of resistance against forgetting. Forgetting is efficient. It allows societies to rebuild without the burden of past trauma. It enables optimism. It fuels innovation. But it also ensures repetition. Without memory, each generation mistakes recurrence for novelty. This may be the central tension of civilization. Memory constrains action. Forgetting enables it. Progress depends on forgetting just enough to move forward, but not so much that mistakes repeat. Cycles exploit this tension. They do not require total amnesia. They require partial forgetting, enough to dull caution, enough to restore confidence, enough to allow complexity to rebuild under the same assumptions that failed before. From this perspective, the greatest achievement of ancient warning systems was not accuracy. It was persistence. They ensured that something survived each reset. Not a solution, but a question. Why did they build this? Why does it align with the sky? Why does time matter here? These questions reopen the possibility of recognition. We now stand in a position unlike any before. We have access to deep history. We can reconstruct past climates, magnetic fields, and cosmic environments. We can compare present conditions with ancient disruptions. We can, for the first time, test whether the stories encoded in stone align with physical reality. This does not grant certainty. It grants responsibility. If patterns exist, and if those patterns have shaped human history repeatedly, then ignoring them is not neutrality. It is choice. A choice to privilege short-term continuity over long-term awareness. Ancient civilizations did not have that choice. They acted with incomplete information, guided by memory and observation. We act with unprecedented information, constrained by institutional inertia. The question then is not whether a cycle will complete. Cycles, by definition, do not ask permission. The question is, what will be remembered when it does? Will our civilization leave behind only ruins and data fragments? Or will it leave behind orientation structures, systems, and knowledge designed not just to function, but to survive misunderstanding? This is not a question about apocalypse. It is a question about inheritance. What do we believe is worth passing through a world that may not look like ours? What do we choose to preserve when clarity cannot be guaranteed? Ancient builders answered this question with stone. We will answer it differently, but the underlying challenge remains the same. In a cyclical world, the future is not shaped by how much we know. It is shaped by what we choose not to forget. In the end, the most unsettling realization is not that civilizations collapse. It is that they do so while believing they have escaped history. Each cycle convinces itself that it is different, more advanced, more prepared, more permanent. And in doing so, it repeats the same mistake in a more sophisticated form. The evidence does not suggest that ancient civilizations were foolish or naive. On the contrary, it suggests that many of them were acutely aware of instability. They adapted. They prepared. They endured as long as conditions allowed. What they could not overcome was scale. Planetary processes do not respond to innovation in the way local problems do. They do not negotiate. They do not pause for readiness. This is the limit every civilization eventually encounters. The 12,000-year cycle, if it exists, does not function like a doomsday timer. It does not announce an end. It describes a tendency, a recurring window during which multiple systems become unstable at the same time. Climate, magnetism, ecology, and cosmic exposure converge, creating conditions that favor disruption over continuity. Under such conditions, civilization is not destroyed in a single moment. It erodes. Systems fail unevenly. Knowledge fragments, memory thins. What survives does so unevenly, shaped more by chance than intention. The past shows that humanity is remarkably resilient at the level of individuals and small groups. We survive. We adapt. We rebuild. What we struggle to preserve is coherence, the accumulated understanding that allows one generation to benefit fully from the experience of the last. This is why the idea of a reset is misleading. Nothing truly resets. Biology continues. Landscapes remember. The planet carries scars. What resets is narrative. Each new civilization tells itself a story of origin that begins after forgetting. We are living inside such a story now. We describe ourselves as the first global civilization, the first technological species, the first to look back far enough to see deep time clearly. In many ways, this is true, but it may also be incomplete. We may be the first to see the pattern without yet understanding how to respond to it. The ancient world left behind warnings without instructions because instructions require context. We, by contrast, possess context without consensus. We can see the signals, but we do not agree on what they imply. We recognize instability, but we disagree on its significance within a longer rhythm. This ambiguity is not failure. It is the natural state of awareness before decision. If the cycle turns again, it will not ask whether we believed in it. It will not care how advanced our tools were. It will test the same thing it has tested before: whether continuity can survive stress. Continuity does not mean preventing collapse at all costs. That may be impossible. It means choosing what endures. It means deciding consciously what knowledge must pass through disruption intact and what can be sacrificed. Ancient societies answered this with stone, symbol, and sky. We have other options: redundancy, distribution, preservation across media and cultures. Not a single archive, but many. Not one narrative, but shared understanding. The danger is assuming that accumulation alone guarantees preservation. History suggests the opposite. The more complex a system becomes, the more vulnerable it is to cascading failure. Complexity without resilience accelerates forgetting. If there is a final warning embedded in the ruins of past civilizations, it is not about impact events or climate alone. It is about humility, about recognizing that intelligence does not exempt a species from planetary rhythms, that progress does not cancel cycles, and that forgetting is as powerful a force as destruction. The cycle, if it exists, does not punish, it repeats, and repetition is merciless only when it is unrecognized. We may not be able to stop the turning of the cycle, but we may be able to change what survives it. That choice, more than any prediction, defines the difference between recurrence and learning. Ancient builders could only hope that someone, someday, would notice the stones and ask why they were there. That hope has reached us. We are asking the question. What we do with it is no longer their responsibility. It is ours. So the final question is not whether the 12,000-year cycle is real. Evidence will continue to accumulate. Models will improve. Debates will persist. The final question is simpler and far more difficult. If this is not the first time civilization has stood here, will it be the first time it remembers standing here when the cycle turns again? And if memory truly is the only thing that does not reset on its own, what will we choose to remember when remembering becomes hardest? Because in a world that forgets itself every few thousand years, the future does not belong to the most advanced civilization. It belongs to the one that understands the clock and refuses to look away as it moves.